Hi guys, welcome back. I think you must have enjoyed the previous session where I discussed very interesting questions from TSSPDCL, right? Assistant Engineer questions. Those questions are really interesting to, try them. With the help of those questions, you can recall a lot of concepts. Okay, I hope you enjoyed that. Now we are going to see network analysis questions, previous questions from TSNPDCL. Okay, again AE. So we're going to see network analysis questions. Okay, the questions from network analysis. Very less number of questions are there. I think 5 questions are there. But you will get some interesting insights out of these 5 questions. I think 3 questions will really, help you to recall a lot of interesting concepts. 2 questions will be pretty straight away and easy questions. Okay, let's get started. Give it a thumbs up quickly so that we'll go to the first question. Yeah, are you guys ready for the first question? Yes, I want you to give it a thumbs up. Yeah, okay. Now let's go to the first question. This is the first question. Let's see. Timer has started. Oops. Yeah, timer has started. Answer this. See, T network is given here. For a T network, which parameters we can find out? It is asked for H parameters, but you can get Z parameters directly. So that's a hint I'm giving. With this hint, you try to answer. Hit that like button, quick. Does it cost you something to hit the like button? You're watching the videos. Does it cost you something? Any video you're watching, if you hit that like button, then it will help YouTube algorithm to spread this content to other people. I think you're too self-centric. You don't want to spread this to other people. That's why you're not hitting it. Is it the case? You're taking advantage of it. Let's others also take advantage of this. Okay. Okay, we already got the answer saying A. Okay. Okay, I'm pausing the timer for now. I'll give a hint. With the help of that hint, I think you'll be, of course, I have already given the hint. The hint is you need to find the Z matrix for this. Yeah, I know it is asked for H matrix, but yeah, it's a T network. For T network, it's easy to find Z matrix. If it is a pi network, it's easy to find Y matrix. Okay, so for this, you quickly find Z matrix. What is Z matrix? This is common, so here 1 and 1. So input impedance 1 plus 1, which is 2. Output impedance Z2 to output driving point impedance. I have told you interesting tips in the course network analysis. I told you some interesting tips to remember these, because if sometimes somebody asks you what is H12, what's the name of H12, how to say what is the name of H12, what is the name of Z12, what is the name of A, all these things, the naming, logic to give the name, okay, and logic to remember these formulas, everything I have given very nicely in the course. I think you must have watch those videos. If you watch those videos, then two-port parameters will be a lot more easier. And why? What's the reason for going for the two-port parameters? All those details are discussed in the course. Okay, and more questions if you keep solving. As I always say, you need to have a good practice of the questions. So how you'll know? Not normally students say, sir, I already understood these two-port networks, but when a question comes, I'm unable to solve those questions. If that is the case, you are missing the practice. You should have a good practice of the questions. That is it. If you're missing the practice, then nothing can be done. Okay, so keep practicing more number of questions. We have thousands of questions in the app. You download the app, then you will get those questions. You try to attempt those questions, then automatically those things will be in your mind. Okay, yeah. So this is a Z matrix. Now H matrix, from the Z matrix, this conversion you have to remember from Z to H, not for all those conversions. From Z to H, try to remember the conversion. Okay, because this will help us in many places. That's why it is frequently asked, frequently used. So try to keep that in your mind at least. So here, I think if we go it by logic, okay, let me write first. 1 by Z22. 1 by Z2 H matrix is equal to 1 by Z22. And here you'll have delta Z, and this is 1. Okay, so this will be Z12, this will be minus Z21. Okay, so this is reciprocal as well as symmetric. That's very clear. Okay, by looking at the circuit, you should be able to say, not for all circuits, for at least some circuit, you should be able to say whether it is reciprocal or symmetric. Okay, I told you also on what basis you are saying it is symmetric by looking at a circuit. Okay, not always, sometimes you can say it directly. So here you can say this is the third term is having negative sign, means B is wrong and C is wrong. Z22 is 2. So 1 by 2 is 0.5, both are having 0.5. So you'll have to figure it out what is minus 0.5 or minus 1, this element. Z21 is 1, Z22 is 2. So this is minus 1 by 2 means minus 0.5. So A is answer, not D. You don't have to go for all terms. Did we try all terms? No, we did not try all terms. We only checked, we only verified few terms. That's pretty good enough. Okay, few terms, if you do it, that's pretty good enough. Okay, I mean, you know to choose which term you should go for. Like, that's where your smartness comes into play. I hope you understood this concept. I paused this to give you tips, but I answered it. It's fine. I think you got the logic. If you're ready, let's go to the next question, which is really interesting. Let's see how many of you will be answering it. Are you guys ready for the next question? Yes? Are you guys ready for the next question? Quickly, thumbs up, thumbs up, thumbs up. Taste the thunder. Yes. Let's move to the next question. You want a hint? Try to convert try to use source conversion, then you will get answer. Okay. The hint is source conversion. Right. Come on, I already gave the hint also. Okay. Now I think it should be pretty quick. You should be pretty quick to answer this question with the help of the hint. If no hint, okay, that would have been a different case. But now I gave you the hint. Now it's very easy to answer. Okay. It's strange. Huh? It's 2 minutes and you're unable to answer it. Really strange. Huh? We have two current sources on both sides. So convert those current sources into voltage source. Then okay. Let's see. Let's see. We got an answer. Answer is B. Yes, absolutely right. Answer is B. Okay. Let's see. Let's see. So power dissipated in watts. Here resistance value is not given. If resistance value is not given, then we know power is equal to I square into R or maybe V square by R. Okay, so either you'll have to find out the voltage across this or maybe current flowing through the resistance R. That's what you'll have to find. Okay, so let's see. Um, Now if I convert this into a voltage source as well as this into voltage source, what I'll get? I'll be getting this side, I'll be getting 6 into 10, which is voltage source is of 60 volts and 10 ohm is as it is, and here resistance R is as it is, and here you will have 6 ohm as it is, and this 10 into 6, which is again 60 volt as it is. Now it's pretty straightforward. You have 60 volts here, 60 volts here, whatever might be the resistance, both potentials are same, so current flowing will be zero. Current flowing will be zero. Do you think any current will be flowing in this? No, right? So if current flowing is zero, what's the power consumed? I square into R. 0 square into R, which is damn double zero. I mean zero, simply. Okay. So are you clear? Are you clear? Yes, Naveen. Yes, engineers. Let's move to the next question then. This question will be really tricky if you don't know exactly the main logic. You'll end up in consuming a lot of time. Okay, if you know the exact formula, then you will quickly able to solve this question, the next question which I'm talking about. Okay, so for in this exam, state electricity board or any other exam except gate, time is a key aspect. You have to have formulas at your fingertips. Okay, directly apply the formula, you will get the answer. Most of the cases, this is what's going to happen. Okay, so for that, practice is the only thing. Okay, so let's, for practice you need more questions. Keep getting questions from different sources. Let's move to the next question. 3 minutes it requires if you go with the regular routine process. If you're smart enough, if you have a good practice already of such kind of questions, 1 minute is pretty good enough to answer this question. Right. If you're watching rebroadcast, you can quickly give it in the comment. Okay, the answer, question number is also given. Question numbers are there here. So write that question number and give the answer in the comment. Okay, can. If you're missing that live, then this is the best what we can do. Wow, Saideep is back with a bash. With an answer, I mean right answer. Okay. Saideep, it's D. Here, more than the answer, the approach is important. Approach is important. You're able to solve this quickly means you got, I think, the right approach. You're going with the right approach. Can you quickly type what's the approach you're following? I think it's easy to type. What's the approach you're following? Can you quickly type? Saideep, really good. Lovely. Oh, we got something popped up for you, Saideep, on screen because you answered it nicely, well within time. Five seconds. I think the time's over. Yeah. Let's see. I was waiting for Saideep approach, but he didn't give it. So let's see. So it is said we have two sources over here. In the circuit shown, the power resistor R is 8 watt. When Vs1 is 12 volt and Vs2 is 0 volt. Means this is short circuit. When it is short circuit, this source, because of this source, power in this is 8 watt. Now, find the power in the same resistor when Vs1 is as it is 12 volt, but Vs2 is not 0, it is 24. So from the superposition, yes, let's see interesting aspect. From the superposition, let me keep this one as 24 volt. This color is indicating for second source active and this is deactivated. Let us take only when this is active and this is deactive. What is the power? What is the current in this? Tell me. That's a first thing you'll have to find out quickly. What's the current in this? If it is 24 volt, what is the current in this? 2 in parallel. 1 is resistance. 1 plus 1 is series. 2 in parallel again. 1 again. 1 plus 2 is 3. So 24 by 3 means here it is 8 ampere. So here 4 ampere. Here 4 ampere. Here 2 ampere. Current will divide equally. Here 2 ampere. Okay. This is a current division just because of this volt. So power will be I square, which is 2 square 4 into 2, which is 8 watts. So when this source is acting alone, we got 8 watt power. When this source is acting alone, we got 8 watt power. So if you apply superposition concept, 8 plus 8 means we're adding up the powers will be 16. That's, you cannot do the superposition for these powers. We cannot use it, right? Voltage you can calculate, current you can calculate, but not for power. Okay, then what to do? So find out the total current, means with this you have calculated this current. Now activate with the help of 12 volts. What is the current flowing in this? Because of just 12 volts, add these two currents and find out the power. So for that you have to find out the current when this is only active. That will take unnecessary 1 more minute time extra. Okay, so that's what the regular way of doing it, but the formula is total power is equal to first power plus second power. This is wrong. The right one is this. Total power under root is equal to total power under root P1 plus P2. So root 8 plus root 8, which is root Pt. So total power is equal to, if you simply solve this, you will get it as 32 watt. 32 watt will be the answer. Check it. Ask me if you have any questions. And now another interesting point, I think I should mention it here. The point is, you can directly add the powers directly if the frequencies are different. And the beauty of superposition theorem comes into play when you have multiple sources with different frequencies. Then there is no other way. In case of AC circuit, if you have different frequencies, means obviously I'm talking about AC circuit. In AC circuits, if you have different frequency sources, then you can't go with mesh analysis, node analysis. All these analysis won't work except superposition. Superposition theorem is the only method which is applicable when you have a circuit with different frequencies. Okay, this is never told usually, but yeah, make a note of it, write it, hard print it in your brain. Okay, let's move to the next question. Ramesh is saying, eagerly waiting for your next course, sir. Okay, buddy. We're also eagerly waiting to launch the next course, but it should be of the same level what our other courses are, right? I think you must have seen our courses like control systems and measurements. All these courses, every next course what you're launching is not just regular way of delivering with the help of interesting animations we're doing. So it is taking some time, definitely. Okay, let's go to the next interesting question. Okay, yeah. This is again another interesting question. Simple question, logic-based question. You might think this one as a gate level question, but if you know the logic, if you have a good practice of the questions, just like that you can answer it. And this question is asked several times in GATE. Not the same question, same concept is asked several times in the GATE exam. Okay, try answering this. I think hardly you need 30 seconds to answer this, maybe, if you have a good practice of questions. And yeah, one more thing, I think you must be looking at the pop-ups, what you're getting there. CL Wadhwa backside questions you will have, right? CL Wadhwa textbook MCQs. Those questions are very important to crack any state government exam, be it state electricity board or anything, okay, regarding electrical. So those in the questions, in the explanation, we have not just given that solution exactly, we also gave little more extra information, we have given in that. Every question you will have a detailed solution will be there in case of CL Wadhwa. And if you just have a good understanding of those questions, then I think most likely you'll be able to solve any question of this level, state electricity board level exam. But if you have to have a good understanding of those, okay. So explanation is very clearly given for CL Vadba. Go for it. Just 99 rupees it is there. You attempt the free test. There are a lot more free tests in the app. Attempt them first. Then you can go for paid test series. Huh? No answer yet. 25 seconds left. Okay. Time's up. So the answer to this question is, careful. In the following circuit, we have a circuit. Understand the question first. At t is equal to 0, switch is closed. The total energy lost in the resistor R is 10 ohm is found to be 60 joules. There are two capacitors over here. This capacitor is having 3 farad, which is initially having a charge of 10 volts, and this is having 2 farad with no charge in it. Which are no charge is there initially. This is having some charge. The moment switch is closed, this capacitor will be discharging and this capacitor will be charging. At some voltage, at some point, both the voltages will be equal. So both the voltage equal means current in this will be 0. So during the process of this discharging and this is charging to some level, there is some power consumed in this resistance, and the power consumed in this resistance is independent of value of R. Whatever might be the value of R, the power consumed will be still 60 joules. Okay, so answer is simply A to this. Of course, you can do the math of doing all those. You do the math, find out the energy, you will get the same. But if you already have a good practice and if you have that conclusion in your mind, simply just by looking at the question within 5 seconds after reading the question, you will be able to answer this. That's what the power of a practice, which is lacking, I think. That's why you're unable to solve it quickly. Anyways, and sometimes they will ask you, you tell me, give it in the comment, what will be the voltage across this and this at t is equal to infinity. At t is equal to infinity, what is the voltage across this? What is the voltage across this? Don't say 0. It won't be 0. It is not completely discharged. It won't completely discharge at t is equal to infinity. So what is the voltage across these two? You do that. This is how, you will be recalling the concepts. If some question is asked during your practice session, it's not that you're only concentrating on that point what is asked. You have to expand. You have to make your own questions from that question. That's how you'll excel. Your knowledge will be expanded. Let's get into the next question. Moving to the next question. Wow. Wow. This is another interesting question. Let's see how many of you are going to solve this on time, accurately. Yeah, the time is already running. It's your call now. This is the last question from network analysis from this TSNPDCL. Okay. Yeah. This is just simple to answer. See the beauty of the question. Very nicely framed question to test your knowledge. Yeah. Yeah. Okay, I think I should give a hint. Let me give the hint. Yeah. Wow. Naveen has answered it correctly. Naveen has answered it correctly. 75. Absolutely true. Option B. And Kumar is saying 6 volt. I think at V is equal to infinity, you must be giving answer as 6 volt from the for the previous question. So what's that? We'll have 10, 3, 30, 30 by 5, 6. Yes, absolutely true. Absolutely true. You're right. You're right, Kumar. Now let's come to this question. Let's come to this question. So three equal impedances. We have three equal impedances. Each one is having 10 plus 10 ohm. They are connected in delta form. Careful, guys. Careful. Three phase. They are connected in delta form. Excuse me. Sorry. So they're connected in delta form, and we got three phase supply is connected. Fine. So it is asking for the angle between the line voltage, line current. This is, let's take it as IR, supply current, and this is R phase, Y phase, and B phase. So angle between line current IR and this voltage VRY. Wow, pretty good. So let me take this current as I1. This phase current I am taking it as I1. So this current is I2 and this current is I3. I1, I2, I3. Now VRY is over here. VYB is over here. This is VRY and this is VYB. This is 120 degrees more, which is VBR. All are 120 degrees displaced. All are 120 degrees displaced. Now corresponding currents I1 will be, I1 is 10 plus 10J means the angle is how much? Angle is 45 degrees. Tan inverse of XL by R, tan inverse of 10 by 10, tan inverse of 1, which is 45 degrees. 45 degrees is the angle. So I1 is 45 degrees lagging to this VRY. Similarly, I3 will be lagging to this VBR by 45 degrees. Okay. Similarly, I2 will be lagging this by 45 degrees. Okay. So I2, I3, I1, I2, I3, they are lagging their corresponding voltages by 45 degrees. That is pretty much clear. So don't think that this is IR. No, this is not line current. This is I1 itself. This is I1, the phase current. But he is very clearly mentioning line current IR. This line current is talking about. Okay. So how can you say this line current is I1 is equal to IR? No, we can't say that. Then now let's make a relation. Let's make a relation between this I1, I3 and IR by applying KCL over here. If you apply KCL, you will get IR plus I3 is equal to I1. Now you find out IR, you find out IR vector, locate it first, then you find out the angle between VRY and IR. Now your timer is running. Go for it. Go for it. Okay. This is really beautiful piece of question. Find IR location first, IR vector. IR is equal to simply I1 minus I3. You know I1 location, you know I3 location. So simply you have to find the difference between these two vectors. You have the phasor diagram right in front of you, right? So use this phasor diagram. That's it. Circuit is also there, and the phasor diagram is also there. Then, and you have the equation. The equation is also given there. Strange, crazy, guys. This is very clear. This itself is very clear. How nice is a preparation? If the I gave you everything and I'm asking you to do this vector sum. And don't say, sir, I don't know these vectors, vector, phasor diagram, all this. I'm not clear with it. Don't bloody say that. In this channel itself, I gave you the free video. YouTube video is there. Phasor diagram video. I told in the previous lecture also, go and watch it. That's going to amaze you. A lot of people are going to love that. And they're loving it. You're also going to love it. Okay. Phasor diagram, PiSquare Academy. You will get that video in the first. And you will rock the phasor diagram. Yet I didn't get any answer. Okay, I'll solve it. What else can be done? IR is equal to IR is equal to IR is equal to I1 minus I3. So this is I1 with 45 degrees, and this is 90 degrees to this VRY. So this angle will be 15 degrees, because this is total is 120 degrees. So this is 30 degrees. So I think you're getting it right. So this angle is 15 degrees. So let me take minus I3 somewhere over here. This is minus I3. Now add this I1 and minus I3. You will get a vector over here. This is what IR, which is root 3 times of this. And this angle is how much? This angle will be 30 degrees. 30? I think no, not 30. Let's find out this angle. How much will be this angle? 45 plus 15. Okay, 45 plus 15 is 60 degrees is this angle. So half of this, which is 30 degrees. So I want angle between VRY and IR. 30 plus 45. I think I'm blocking this phase diagram. So this is 30 and this is 60. So how much? 30 plus 45, which is 75. Answer is B. Bang, bang. We got it. How simple is this? What happened? Saideep? Yeah, Saideep. Huh? I'm really not happy with this. Yes, I am angry. Okay. I gave you the points also, yet you're unable to solve it. So, I'm feeling sad about it. Okay, anyways. Only Naveen has answered it, but others, no answer. Okay, let me end this session over here. I think you got some interesting insights. Did you get it or not? We solved 5 questions out of 5. I told you, right? 3 questions are really amazing, and the second question also really interesting question. Okay, source transformation. Okay, but next first question number 3 and 4 and 5, I think they are good. Okay, so let me end this because these are the only questions for network analysis. Okay, so yeah, catch you up in the next session. Bye. If you have any questions on what I discussed so far, you just let me know. Do you have something based on what I discussed and what you need to do? Yeah, CL Wadhwa, download the app. You'll get a lot of free content, other previous year questions from other state exams. They're also discussed in the video. All those videos you'll get it in the app. Download the app. You'll get all those things in one go. Okay, that's it. Bye bye. Catch you up in the next session. Um, yeah, खत्म करो.